and welcome to our presentation on the decommissioning of nuclear facilities, the replacement of Cobalt-60 sources in gamma knife machines. My name is Paul Van Gent, and my teammates are Amal Kadam, Seth Brannon, and Corbin Harold. We are mentored by Dr. Alina Polanova. Next slide, please. Before we explore the decommissioning, it is important to understand why decommissioning is done. By decommissioning, we can ensure that nuclear non-proliferation goals are achieved by continuing to secure nuclear sources. Decommissioning also ensures that work is done to restore the environment after a facility is closed down. Decommissioning's importance is shown by prior accidents that have occurred from improper or incomplete decommissioning, with the largest accident that occurred from incomplete decommissioning being the accident in Goiânia, Brazil. This accident resulted in a source capsule being breached and radioactive contamination being spread into the city. Next slide.
So for our project, we wanted to narrow down the topic of decommissioning nuclear facilities to something that was specific enough for us to study and explore in depth. And we decided to focus on gamma knife machines, specifically the one found at the Abermackennin Hospital. Now, these gamma knife machines are an awesome piece of technology that are used to treat brain tumors and abnormal blood vessels through high levels of precision-guided gamma radiation. And these operations are relatively uninvasive, they have a short recovery time, and they only require a regional anesthetic, making it a very quick and easy process on the patient. Next slide, please. So the way these machines work is a patient is set down on the bed and then moved inside the machine, and then the bed is rotated and shifted in its position so that the focus point of the radiation changes in the patient's head. Now, this radiation can be focused down to the millimeter, allowing for extremely precise applications of the radiation, allowing it to target very non-conventional geometries within the head in multiple doses, or to contact very small targets without affecting the surrounding tissue. So the way we decided to break up the project is to look at the three different agencies or groups that would be involved in a decommissioning process. We wanted to look at the hospital side, managing the decommissioning and coordinating with both the government and third parties. We wanted to look at the government side of the project and the regulatory oversight that goes into a decommissioning project. And we wanted to look at the hands-on radiation protection and safety side, where a company comes in, sets up the appropriate machinery and equipment, and removes the sources safely.
The primary sources of the regulations and guidelines followed for nuclear decommissioning are from the IAEA, the International Atomic Energy Agency, and the NRC, the Nuclear Regulatory Commission. The IAEA is a UN-associated agency that works with the nuclear nations around the world to increase safety for peaceful nuclear activities. They produce guidelines that they recommend nations base their regulations on. The NRC is the primary nuclear regulator for the United States and has the most of the relevant regulations in the Code of Federal Regulations. The most relevant regulations can be found in 10 CFR 30, 35, 50, 51, and 71, with most of the remaining requirements being on the NRC website. Next slide. Before decommissioning, it is necessary to understand who has regulatory authority over the process. Because the Abermackennin Hospital is in South Dakota, which is not an NRC agreement state, we know that the NRC is the primary regulator and the process will have very limited state involvement. Additionally, because we are focusing on the gamma knife machine at the Abermackennin Hospital, and the NRC is the only government agency that regulates gamma knife devices, the only relevant regulatory authority for this decommissioning is the NRC. Next slide.
The following timeline breaks down the decommissioning operation by months, 6 months, 3 months, and 1 month. During the 6-month mark, The hospital personnel will start and initiate the planning stage of the decommissioning by contacting the Radiation Protection and Safety Agency and submitting all the essential forms to the NRC if needed. At the 3-month mark, there will be a need to submit floor maps and specific guidelines for the machine to the Radiation Protection Agency. On the 1-month mark, there'll be a lot of safety planning and recording expected dose levels. At each point, there'll be a lot of government regulation reviews and to make sure that everything is going within regulatory guidelines. So the first step in the hospital management, as I've mentioned, hospital personnel will initiate the decommissioning planning process by contacting the contracted Radiation Protection and Safety Agency. What we need to know about this hospital personnel is that they must be registered and approved by the NRC. The personnel will submit their certification and academic records for approval before this whole process starts. And in the future, any machine operators will have to register using the same process through the NRC using the application for material license. The second step will be submitting accurate floor plans to the Radiation Protection Agency. This will help both the hospital and the Radiation Protection Agency to plan an exit strategy or calculate accurate dose, expected dose. The hospital management will provide financial assurance and keep record of all transactions. This is also following regulation from the NRC, SFR 3035, financial assurance and record keeping for decommissioning. It is required by law that the hospital will put aside $113,000 just for the decommissioning operation of those Cobalt-60 sources. And lastly, the hospital will create a safety plan for the decommissioning. And this will include ensuring that no procedures are scheduled for the day of decommissioning and 2 days after the decommissioning is completed, ensuring that only essential workers will be working on the day of decommissioning and distributing dosimeters to keep a record of dose.
Now, regarding the actual radiation safety plan, there are a couple of pieces of regulation that we need to make sure that we're staying within so that we're keeping our workers and the general public safe. The NRC has set annual radiation dose limits that are both different for nuclear workers and the public that the licensee has to make sure that we stay under. For the workers, that means 5 rems total effective dose equivalent. And for the public, it's 0.1 rems total effective dose equivalent. And in any unrestricted area or an area where any random person could walk through unrestricted without being stopped, there has to be a dose rate of less than 0.002 of a rem per hour. Next slide. So how we're going to accomplish this is through the use of dosimeters. Now, dosimeters are devices that can be worn or placed in an area to measure the exposure to radiation in that area or on that person. Dosimeters, however, are not what's keeping you safe from radiation. All a dosimeter does is it sees how much radiation you've received. And this is important in making sure that our safety plans, our shielding, the time we spend around radiation and how far away we keep people from the radiation is actually working and keeping the exposure to radiation low for those individuals. So we'll be handing out personal dosimeters to all nuclear workers that are involved with decommissioning directly. These dosimeters will be Polymaster PM 1610 personal dosimeter badges that can be worn on their uniforms. We'll also be using similar dosimeters that will be placed in the area around the decommissioning. This includes the room of the Gamma Knife machine, on the Gamma Knife machine, and all of the hallways and corridors that the Cobalt-60 sources will be moved through during the decommissioning process. We'll also be placing these dosimeters around any common space where non-hospital staff may pass through, making sure that these unrestricted areas dose stays low.
Before the sources are transferred, there are a few government requirements that must be met. Among them is the requirement for the Hospital and Decommissioning Agency to complete NRC Forms 741, 748A, and 748C, which are used for the purposes of tracking sources. Form 741 is a form to track the sources for the IAEA, and Form 748A and C are for the NRC's records. Additionally, if the decommissioning workers do not already have clearance to work on the Gamma Knife device, they must request and receive authorization from the NRC by submitting NRC Form 237. Next slide.
Now, regarding the actual plan for our workers, what we're going to be having them doing is removing the sources from the machine and then moving them through the hospital and placing them in a cask outside for transportation. A two-man team will work on loading the sources from the machine into a cart that is shielded and then moving that cart through the hospital. It'll take 5 minutes to load 50 sources into the cart and seal it, and it'll take 4 trips to get all 192 sources in the cart. And it will take the same amount of time to load the machine, to load the cart from the machine into the cask and vice versa. Moving the cart through the hospital, 1 operator and 2 safety walkers will drive the cart through the building to the Type B cask that's outside. Everyone will be required to stand at least 20 feet away from the cart to minimize this exposure. And each trip will take roughly 20 minutes to get the cart from the inside of the hospital to the outside. Looking at how much radiation we expect our workers to receive, we first look at how active the sources are. Now, when we're decommissioning these Cobalt-60 sources, their activity is going to be very low. So we anticipate an individual activity of each source of 1 curie coming out of the machine. And the new sources that we will be bringing to the facility will have an activity of 34.2 curies, which is much higher. We expect the workers to receive a dose of no greater than 0.05 millirems during the transportation of the Cobalt-60 sources. This is moving them from the machine to the truck outside and from the truck to the machine inside. And we expect no more than 5.3 millirems of radiation dose for our nuclear workers while they're actually handling the sources directly, moving them from the various containment systems and into the machine. Total, we're expecting less than 6 millirems per worker and less than 0.05 millirems for anyone in the general public. Next slide.
Once the used Cobalt-60 sources have safely made it out of the facility, it's time for transportation to disposal. South Dakota is a non-agreement state with the NRC, meaning that the NRC has regulatory authority for radioactive license in South Dakota. 2 possible ways of disposing of the used Cobalt-60 sources include 1, being sent back to the manufacturer for reuse or recycling, and 2, sent to a low-level radioactive waste facility permitted by the NRC. For this case, we will be sending it to a low-level radioactive waste facility. The disposal facility that accepts Class A, B, and C low-level radioactive waste generated in South Dakota would be known as Waste Control Specialists, located in Andrews, Texas. In order to get the sources there, a petition would need to be filed with the Southwestern Low-Level Radioactive Waste Compact in order to export this waste from South Dakota. Each state's authorities must be notified when a shipment is traveling through, and police escorts will have to be present during the transportation. Next slide. Packaging for transportation. The used Cobalt-60 sources will then be placed in a Type B cast used for Category 1 sources, and must be able to withstand all elements without breaking sealed containment. This is tested through a number of tests that include a 30-foot free fall drop, a 40-inch drop on a steel rod, and heating the package up close to 1,000 degrees for 30 minutes, and finally an immersion in water 15 feet down for 30 minutes. This ensures the containment abilities of the package. 10 CFR Part 71 packaging and transportation of radioactive materials, along with 10 CFR Part 73 physical protection of radioactive materials, are very important during transportation. Next slide. The waste control specialist in Andrews, Texas is located at that red star, the southern star in Texas. And our hospital is also located in South Dakota on the most northern star. The Cobalt-60, once it reaches this point, will be placed underground where it will stay for approximately 30 years. Next slide. Security during the process. There's source tracking through Transcom, which is put on by the Department of Energy and is used by DOE shippers and a couple other agencies during transportation. And also the National Source Tracking System put on by the Nuclear Regulatory Commission that it's used through the duration of the entire source's life. Weather should be considered through the entire transportation and should be monitored throughout the trip to ensure that there's no bad weather that we run into. An emergency preparedness plan should be made prior to any step of transportation for the entirety of this process of decommissioning.
If the decommissioning encounters no problems, then the work is complete once the necessary forms have been sent to the NRC. If a minor problem arises that does not require immediate intervention, then the hospital and decommissioning agency need to submit NRC Form 366 to the licensee event report. If a major problem occurs, with the worst case scenario being a rupture of a source capsule outside of the Gamma Knife machine or a transport cask, then the hospital may need to be evacuated. The NRC must be immediately and directly contacted, and NRC Form 366 will still need to be submitted. The NRC will then thoroughly investigate any problems and resolve the situation as needed. Next slide. And with that, our decommissioning is complete.